Let me have your attention. We're on the skeleton crew today because of PSATs, and also we have stats. There it is. We have goals. First goal is to talk about notation for derivatives. And the second goal is to talk about product rules for derivatives. And we're going to do product rule today and tomorrow. Because there's going to be a surprise. We're going to need some time to get used to the surprise. Yes, sir.
Wait, will the product rule be on the quiz tomorrow?
No. It's going to be derivative rules up through power.
Derivative rules up through power.
Yep.
And is the quiz like 1 page?
Yeah.
Okay.
It's going to be fairly short and sweet. All right. The first thing that I want your attention about is the notation. I've been getting homeworks from almost all of you, and that is good. You're getting the homeworks back with a lot of red on it, and that's because the language needs to be cleaned up. That's not a surprise to me. You're learning a new language. You got to figure out how to get those details under control. But when we talk about right and wrong ways to write what you're doing.
I can get mine back.
Let's see here.
Oh, because they're all in a stack.
Okay. Christine, Sophia, Sean. You are Sean. And is Megan at the PSAT? Which is out. And Brian?
Yeah.
Yes.
This right here.
Uh-huh. Right. That's correct. Good. And I will talk about that. Okay. Notation. Let me talk about the notation, the proper notation to use for a couple of these. If I have y equals 6 minus 2x, and I have to find dy dx, the first thing to understand is that dy dx is a rate of change of y with respect to x. And you can read that straight off the notation. It is a noun. Okay. Meanwhile, the way that we find dy dx is to differentiate this thing. And the verb differentiate is spelled in math like this. So ddx is an operator that takes this thing on the inside and returns its rate of change with respect to x. Does that make sense? So the way in which I would write this is dy dx is ddx of. And then I go through and apply my derivative rules. This is a linear function, so I get -2, and I'm done. How does that work out when we differentiate an unknown function? So for example, if I have the derivative of f of x plus 3g of x at x equals 1. Well, if I appeal to the sum rule and constant multiple rules, then I can immediately write that as d dx of f of x, still evaluated at x equals 1, plus 3 times the derivative of g of x, still evaluated at x equals 1. And now, watch closely for the notation. What I'm going to get is the rate of change of f with respect to x, that's spelled f prime, evaluated at x equals 1. Plus 3 times the rate of change of g with respect to x, evaluated at x equals 1. Look at the notation carefully here, because there were several things that people were doing that were not equivalent to this. And the biggest one that I saw is we do not want to write ddx of f of 1 plus 3 ddx of g of 1. And the reason we don't want to write this is that f of 1 is actually a fixed point. It is a constant. It is a number. And it has no rate of change. So this actually creates Zeno's paradox. If I stop x right at 1 and then try to find its rate of change, I get 0 every time. So this quantity right here would be 0 no matter what f of g are. So we are not going to do this. Instead, we're going to do this. Our slogan, differentiate first, then substitute.
Wait, so the issue in this is that you don't have such as x equals 1.
No, the issue is that I substituted x equals 1 before differentiating. And when I substitute x equals 1 before differentiating, I create Zeno's paradox. I freeze at a moment in time.
Okay.
I stop the movement.
Okay.
Did I help?
I'm not really sure I understand. But
Okay.
I like, so when would you use dy over dx?
You use dy over dx to describe the rate of change of y with respect to x.
Okay.
Yep. So dy dx is a synonym for y prime.
Okay.
Okay? Whereas you would use ddx of as an operator, as a verb that takes a function and returns its derivative. This is what you use when you want to do something to an expression.
While this would be dy over dx.
Oh, I may have misunderstood what you're writing. Because there weren't brackets there, I couldn't see what you were doing. Oh, then that would be ddx. That would be ddx.
Which is the rate of change of idea.
But that is dy dx.
It's like
And then you say ddx. So I'm misunderstanding.
Alright, got it. That's fine.
Better?
Yeah,
Good. Yes, ma'am.
What is when x equals
Okay, if you need to. All right. Yes, we are.
Oh, God, okay.
Are there any other questions about notation before I move on? Yes, sir.
I want to do a problem, like find dy over dx if y equals to 4x plus 7 minus 2 and the absolute value of x.
Mhm.
It's not too.
Like that? So in terms of notation,
Oh, I'm sorry, there's a plus. In, yes. Thank you.
in terms of notation, I'm first of all going to say dy dx equals. Why? Because they told me to find dy dx. So I'm going to, this is like that old, if you have to answer a question, you start off by saying, what is your name? My name is. So this is find dy dx, dy dx is. Now, how do we find dy dx? We find dy dx by differentiating this thing. And so I use that language, ddx of, to say I'm differentiating that thing. Now I walk through and I ask, what derivative rules apply here? Well, looking ahead, I can see two functions that are very friendly to me. There's one and there's the other. This is a linear function, that's an absolute value. It's multiplied by -2, but I know how to handle it. And so I'm going to, this is actually from the first night's homework derivative. And so I'm going to first appeal to the difference rule for derivatives. Like so. This is when I'm moving carefully one rule at a time, right? In real life, I just walk down a term at a time and take derivatives because I'm comfortable with the difference in constant multiples. And then here I have a linear function rule, so its derivative is going to be.
4.
And here I have a constant multiple rule. So I use the constant multiple rule to move that constant to the left side. And now the derivative of the absolute value of x is?
X over at the absolute value of x.
And since this is equal to dy dx, I just repeat myself and we're done.
I don't have to simplify that.
I don't know how to simplify it. I could, if I wanted to, observe that this will be 1 when x is positive and -1 when x is negative. So I could rewrite this as 4 minus 2, or 2 when x is positive, and 4 minus -2, or 6 when x is negative. So these two are synonyms for each other, but I like this better.
Okay.
Yep.
So Are ddx and limit as h goes to 0 interchangeable?
Ah, okay. Good way of putting it. So let's talk about that for just a minute. This is profitable. I'm happy with this. Okay. So this is our definition of derivative right here. If I were to use y, I would also write this as dy dx or y prime dx equals the limit as h goes to 0 of y of okay. Like so. Now, this is also a synonym for ddx of y, right? So you can see that the process of taking the derivative of y with respect to x is equal to the process of taking the limit as h goes to 0 of the difference quotient.
Okay.
Okay? Yes, sir.
Did you get my photo book yesterday?
No.
Okay, well, it was about the homework we did last night. I didn't, well, I understand now, like, at first I didn't understand, like, doing my line.
Oh, good. Yes. A couple of you are confused about what you're supposed to do. For example, when you walk into my class, you're supposed to spit out your gum. A couple of you are confused about what you're supposed to do, and I want to observe two different questions. Okay, so everybody look at this question here. Now we're going to change one word, and this is going to change what we're trying to find. Okay, and the one word we changed here was, here I want its slope, here I want the equation of the tangent line. Guys, please pay close attention to this because some of you are answering the wrong question. If I want the slope of the tangent at x equals 2, I am going to spell that f prime of 2. That's the slope of the tangent at x equals 2. And to find f prime of 2, first I need to find f prime of x by using my derivative rules. And now we have enough experience that we can do this in our heads, term at a time. Derivative of x squared is? The derivative of 3x to the 4th will be? Isn't that nice? I will. Yeah.
Yeah, multiply by 3, okay.
Yeah, that's right. And so f prime of 2 now will be found by substituting in, which gives me 2 times 2 plus 12 times 2 cubed, which is large. That's 4 plus 96 is the third.
Did y'all just like do that in your
12 times 23 is not 100.
No, 12 times 2
times
cubed
Oh,
is 96.
Did y'all just like do that in your heads? Like to find out the.
Y'all did?
Wow.
smart mistake.
Experienced.
No wonder.
12 times 8 is 96 plus 4 says
Oh no, I'm talking about like so like.
Oh!
Hey, you did.
Oh, yeah.
That's how you learn.
Yes,
That's
they
how
did.
we learn the power.
They use the power.
That's how we learn the power.
Bring down the power, subtract 1 from the power.
Yeah.
Bring down the power, subtract
How
1
many
from the
pages
power.
do you have?
Constant multiple.
Yeah, I was just like, because I was like trying to comprehend what was going on.
Yeah, yeah. It goes that far.
But it's still limited, the entire homework to limit.
Yeah. Situational awareness, my friend. Yes, sir.
That must have taken you hours.
Okay, let me finish this up and then we'll talk about that. This is productive because we're getting a lot of questions answered. The one thing we didn't get to is product rule. I think I'll have to do it on video. I don't know when I'm going to have time, but we'll make it happen. Because you need to know product rule for tonight's homework or you're going to be lost. Yeah.
So when the question asks construct the line tangent to the graph of,
Yes, that's asking for the equation.
okay,
Now, this right here is my slope. When I need an equation, I need both a slope and a point. Exactly. So I'm going to start my equation by writing down the two pieces of information that I need, the slope, which is spelled f prime of 2, and the point, which is spelled 2 comma f of 2. Does everybody see the distinction that we've got going on here? And f of 2 is found by plugging in 2 squared is 4, plus 3 times 2 to the 4th. 2 to the 4th is 16, times 3 is 48, plus 4 is 52. And finally, I want to jump up and down and fuss about a little thing, and that is that since you have a slope and a point, which form of line should you use for this? Point slope. And should you simplify this line?
No.
No, not unless you need to use it for something. I seriously had people on their homework correctly give me the line and point slope form and then come back and simplify it wrong. What? Extra time and the wrong answer. It's a two for one bad bonus. Okay. Yes, sir.
Okay, so for problems like,
Sydney's next. Her problem is next.
Alright.
She wanted to know horizontal tangents.
No, I know that one. It was the line.
And Sydney, what's the first function that you are given?
F of x equals x minus x squared.
And so the key thing is to understand what it means to have a horizontal tangent line. Let's draw a picture so that it's clearly visualized in your mind. If I have some function f of x with a horizontal tangent line, that horizontal tangent line has a slope of 0. And so the way to translate this into math is to simply say that f prime is equal to 0. That's it. And then we can come back and apply the details. Horizontal tangency is equivalent to the derivative is equal to 0. Does everybody see why? And so now it's just a matter of supplying the details. I can find f prime by walking through and doing derivative term at a time. The derivative of x is 1. The derivative of root x is? Exactly so. And that's our derivative rule. And that has to equal 0. And now I can solve this equation by clearing the fractions, multiplying both sides by 2 roots x. And when I multiply the right-hand side by 2 roots x, I still get 0. And when I multiply the left-hand side, I get 2 root x minus 1. In other words, 2 root x equals 1. In other words, root x equals 1/2. In other words, x equals 1/2 squared over 1. Yes, sir.
Yeah, I just want to make sure I did this right. For the first one, for the fractions, I kind of took the x squared out, and I just want to make sure I got it.
Good. So what's the y equal to?
Y equals x to the fifth minus 6x over x squared.
Yeah. Please observe that if I'm finding y prime or dy dx, I do not have a rule yet that lets me find the derivative of a quotient. I do not. And so I cannot do anything calculus-wise with this. So if I'm going to be successful, I am first going to have to use some algebra to simplify it to get rid of that quotient. That's my only hope. Good. And so that means using algebra to rewrite division as multiplying by the reciprocal, like so that I can now rewrite x to the 5th divided by x squared is x to the 3rd, minus x to the 4th divided by x squared is x squared, and now I can take the derivative of this thing. The same thing happened, Cliff asked about this one. The derivative of 2x plus 3 squared. Here's where I need to be really clear. This looks like a power rule, but it is not exactly. our power rule is literally d dx of x to the n equals nx to the n minus 1. This is not x, it is 2x plus 3. And we're not sure yet how that's going to affect things. We're going to have a way of dealing with that called the chain rule in the future, next week. But for now, I do not have the possibility of using the power rule on this because this is not literally x. What can I do? All is not lost. I can appeal to algebra to simplify this. And when I square 2x plus 3, I get 4x squared plus 12x plus 9. And now I can walk through and take the derivative term at a time. If I try to apply the power rule to this directly, I will get the wrong answer. Does that make sense?
We can go back to the last one, just like the
Mhm.
division.
Sure.
Okay, yeah, okay.
All of this here is algebra, and because it's algebra, I am holding off on applying that derivative operator until I get this in the form that I can actually differentiate it. Does that make sense?
Yeah.
Yes, sir.
I was doing, the line tangent of a graph. I did all the math right, but I got different answers for each of that.
Okay, let's see. I can make sense. Which one?
Number, g of x equals x squared plus factorial x.
And what point of tangency?
Oh, 4.
4. All right. And so we need slope, and we need point, and we're going to spell that as g prime of 4. And we're going to mark our point as 4 comma g. Did you write all this?
Yeah, I have, yeah.
Perfect. All right, let's do g of 4 first because it's easy. What do you get for g of 4?
18.
I get 16 plus 2 is 18. Good. All right. What do you get for g prime of x?
G prime of x, 8 over 4. Oh, 8 over 4. 8.25.
Huh. No, g prime of x. I want g prime of x first, and then we will substitute.
Oh, sorry, 2x plus 1 over 2 divided by x.
Okay, good. And so then g prime of 4 would be equal to 2 times 4 is 8, plus 1 over 2, which is 0.25, and I get 8.25 also. So we agree now on our numbers here. And so we should get y minus 18 equals 8.25 times x minus 4.
Okay.
That's what I get. Right here.
You got 0.5.
Oh! Yeah, I'm in.
What?
All right, guys, look for a video on finance. That video will probably be 15 minutes, something like that.